Alright, this is Mr. Gillum, and today we're going to start graphing exponential decay functions. Not to worry though, they're very, very similar to exponential growth functions. Alright, exponential functions, okay, all of them. Growth, decay, everything, in the form of y equals ab to the x, okay? In exponential decay, the growth factor must be between 0 and 1, so it must be a fraction less than 1. Okay, and that is the difference between exponential growth and exponential decay, is the growth factor. Okay, and so I didn't really put any examples up here, but there is a section in your homework where it says, tell whether the function is exponential growth or decay. So let's just do a little example here. If it says y equals 3 times 2 to the x, that would be exponential growth. 2 is not between 0 and 1. However, if it said y equals 3 times 1/2 to the x, the growth factor b is in between 0 and 1, so it would be exponential decay. Okay, it'd be exponential decay. All right, same way here. If it said y equals -3 times 4/5 to the x, once again, the negative has nothing to do with it. I'm just looking at the growth factor. If that's in between 0 and 1, a fraction in between 0 and 1, then I know it's exponential decay. It could even say something like this, okay? Y equals 5 times 0.3 to the x, okay? As long as that growth factor is in between 0 and 1, it's exponential decay, all right? Now, that's what this statement says here. The growth factor b is in between 0 and 1. Now, as you can see, not in between 0 and 1, growth. All these other ones, 4/5, 0.3, decay. They're all in between 0 and 1. The rest of it doesn't matter, okay? The exponent, the x is in the exponent, that tells us it's an exponential function, okay? Exponent, exponential function, the x is in the exponent, and the growth factor, the b value, the base, tells us that it's whether it's exponential growth or decay. So real quick, I just want to stress this again. If we have y equals 3 to the x, okay, there is an a value and a b value. Okay, remember a comes first. These are all my a values. And b comes second. The growth factor has the x in the exponent. See how x is to this power right here? That's the growth factor. On this one, this is my b value, my growth factor. It's a growth factor of 3, so this would be exponential growth. Okay, I do have an a value. It's a 1. There's always two numbers there. It's very important. Okay, so let's go on. Today, okay, we just kind of talked about this. Okay, I'll just reiterate. Growth factor is greater than 1, exponential growth. Between 1 and 0, exponential decay. Okay, and we know that the growth factor is never a negative number. B is never a negative number, and we covered that before. The growth factor can't be negative. Okay, only the a value would be negative, and the a value changes whether it's above the x-axis or below the x-axis. One thing I do want to talk about, though, is why it becomes exponential decay. And just to give you an idea, this is what an exponential decay function looks like. Okay, it's going to go down today. All right, very quickly, exponentially fast. It's going down towards that asymptote that we know is there. All right, and the reason the growth factor has to be in between 0 and 1 is because it's a fraction, and when you take a fraction to a power, 1/2 squared, that's 1 squared over 2 squared, 1/4. As you can see, 1/4 is less than 1/2. And if I had a growth factor of 0.3, and I was plugging in 3, that would equal 0.027. Okay, as you can see, 0.027 is less than 0.3. So it actually gets smaller because you're actually taking a fraction to a power. The numbers get smaller and smaller. Okay, anything else like yesterday, okay, growth factors, if you take 2 squared, you get 4. If you take 3 squared, you get 9, okay, and it gets bigger, faster, okay? When you take a fraction to a power, though, it gets smaller, faster. That's why if the growth factor is between 0 and 1, the numbers, your outputs get smaller and smaller and smaller. So today, we're going to just, once again, we're just going to graph like beginners, okay? Just a t-chart from -2 to 2, like the first day of exponential growth. We're going to plot the points, connect the dots with a smooth curve, and as x gets bigger, y gets closer and closer to 0. Okay, they're actually, just like the first day of exponential growth, there's actually going to be an asymptote at 0 for all these graphs. Okay, so let's go ahead and start. It says graph the exponential decay function, state the domain and range. Okay, so let's just remind ourselves that's x and that's y. Okay, so for today, we're just going to do a t-chart. Now remember, there is an a value out there of 1. The growth factor in this problem would be 2/3. It is between 0 and 1, so I know it is exponential decay. Okay, 2/3 is in between, my growth factor is between 0 and 1. Okay, it's a fraction, so I know it's exponential decay. So let's just do our t-chart. -2, -1, 0, 1, and 2. And we're going to say y equals 2/3 to the -2. And all these things. I'm going to write them out for you. And we'll do y equals 2/3 squared. Okay, let's start with the very top. Negative exponents. What you can do with a negative exponent is flip the fraction over. So really it's 3/2 squared. Okay, see how that negative went away and I flipped the fraction? That's what the negative exponent does. 3 squared is 9 and 2 squared is 4, so 9/4 is my first value. That negative up there makes it 3/2 to the +1, but we know anything to the first power is just itself, so 3/2 would be our second value. Anything to the 0 power is 1, so that's an easy one to put in. And 2/3 of the first is just 2/3. And 2/3 squared is 4/9. Square the top, square the bottom, 4/9. Okay, and let's put these on a graph and see what it looks like. Okay, -2 9/4. Right about there. -1 3/2 right there. 0 1. 1 2/3. 2 4/9, and as you can see, it's getting closer and closer to 0. So we're going to go ahead and assume there's an asymptote there. I'm going to tell you there is one there. Okay, the rules are going to apply to exponential decay just like they do for growth. Okay, and the equation of that would be y equals 0. It's a horizontal line at y equals 0. And so I'm going to connect these dots with a smooth curve, and I'm going to be careful never to cross the x-axis because there's an asymptote there, and we're not going to cross that. Okay, and so they look really similar to exponential growth. Okay, exponential growth functions look something like this, where they got big really fast. Well, exponential decay, they go the other direction. Okay, they go from the top to the bottom, down the hill. And so you have a pretty good looking graph here. All we have to do now is just talk about domain and range. The domain is anything left and right. So the farthest point to the left, farthest point to the right. Looks like it goes left forever, looks like it goes right forever. Okay, so we're going to say all real numbers from -infinity to +infinity. The range is anything y can be, from the smallest to the biggest. Now, in an exponential decay, it comes really close to 0, but it never touches. But 0 is our boundary, so I'm going to use 0 with a parenthesis because I don't want to include 0. It's never going to actually touch 0, just come really close. The highest point is +infinity. Okay, it goes on forever, up. Okay, it goes up forever. So there's your domain and range as well. Okay, very, very similar to exponential growth. The only difference is today is that the growth factor, the b value, is in between 0 and 1. That's really, really important that you understand that. Okay, let's do another one. There's the y-axis and the x-axis. Okay, and let's just check it out here. We're going to do a t-chart from -2 to 2. And just before we get started here, I noticed a few things about this one. I see a negative here. So I'm going to predict that all my values are going to be on the bottom of the x-axis. Okay, that's what my a value almost always does in all our equations. I see that 3/4 is in between 0 and 1, so I know it's an exponential decay function. And so that tells me a lot just by looking at those two values. So let's just check it out here. We have y equals -2 times 3/4 -2. Y equals -2, 3/4, -1. Okay, and I do want to show a little more work this time because these are a little trickier once you get a few more numbers in there. Okay, a lot of people are tempted to just cross cancel right off the bat, okay, and something like this But remember, you have to actually use order of operations and do the exponents first, okay, the powers first. This negative right here is going to flip the fraction over. So really this is negative 2 times 4/3 squared. I'm going to square the top and the bottom of my fraction before I multiply. So negative 2 times 16 ninths. I'm going to multiply straight across. There's nothing to cross cancel, so negative 32 ninths is my actual solution for negative 2, my output for negative 2. Negative 32 ninths. Okay, once again, I'm going to go ahead and use this negative 1. I'm going to write negative 2 times 4/3. Now I could put it to the first, but we know that it's not going to change anything. Now I'm looking to cross cancel. I don't see anything, so I'm going to multiply straight across. Negative 8/3. If I plug in 0, okay, negative 2 times 1, because anything to the 0 power is 1. That's negative 2. And as you can see, hopefully, that a value, once again, we're going to get a y-intercept at that a value. Okay, we don't have any h or k's or anything, but that's really important right there. Okay, that's going to come into play tomorrow, just like exponential growth. And then we plug in 1. We have negative 2 times 3/4. I'm going to go ahead and cross cancel this time. That gives me negative 3/2. And then for 2, I'm going to go ahead and square it first. Make sure you always square it first. Negative 2 times 9/16 equals negative 9/8. Okay, so that's what we have. And let's take a look here at our graph. We're going negative 2, negative 32 ninths. 1, 2, 3, a little more than 3. All right, negative 1, negative 8/3. A little more than 2. 0, negative 2, right there. 1, negative 3/2, right there. 2, negative 9/8, getting closer. Okay, and it's going to get getting closer and closer and closer to 0 actually. So I'm going to go put a dotted line. Okay, I'm going to just tell you today. I know you don't know the rules yet for exponential decay, but they're the same as exponential growth. That k value is going to move the asymptote. So, but for today, y equals 0 is our asymptote for all of our problems, because they're very, very beginner problems. Okay, and we're just going to connect the dots and make it go close to 0 but never touch. Okay, it's never going to go through the y-axis. There's an asymptote there. All right, so got a good look at exponential decay function, and once again, I predicted before that this negative sign out here would make all our values go to the bottom, and it did. Okay, so let's just talk about our domain and range now. The domain, anything left and right, so obviously it goes to the left forever and to the right forever. And the range, from the smallest point to the largest point, now the smallest point, well, it goes down forever. The graph goes forever to the bottom, so negative infinity, somewhere down there. And then the highest point would be at 0, but it's never going to touch 0, but 0 is the boundary for the highest point. So we're going to just go put a parenthesis on that 0 there. Just want to look at one more. And once again, there's a few things I can tell just by looking at it right away. I see this is positive, so I think it's going to be above the x-axis. This number is in between 0 and 1, so I know it must be exponential decay. If it's anything bigger than 1, it's exponential growth. Anything less than 1, exponential decay. And sorry, anything less than 1, bigger than 0. But here we go. Let's just take a look. For today, we're just doing t-charts. And I'm just going to plug these values in here. F of negative 2 equals 4 times 1/5 to negative 2. And just do a little busy work here. And let's just get it done real quick. Okay, remember this negative exponent, that flips the fraction, so we're going to say 4 times 5 over 1 squared, which is really just 4 times 25, which is 100. Okay, so there's our first value. Plug in negative 1. Once again, we're just flipping this fraction around. Times 5. 5 over 1 is the same as 5, so 20. We're going to say anything to the 0 power is 1, so this is really 4 times 1, 4. This is really 4 times 1/5, 4/5. And this is really 4 times 1/25, which is 4/25. So I'm just going to put my numbers in here, 4 4/5, and 4/25. And let's take a look at our graph now. X and Y, and -2 100, way up here somewhere. Okay, way up there. -120, still way up here. Let's just put it right there for now. 0 4, right there. 1 4/5, right there. And 2 4/25, so really close. Okay, and once again, there's going to be an asymptote at y equals 0. Okay, no matter what number I plug in there, you'll never get a value below 0. Okay, so there's an asymptote there. You're never actually going to get 0 either because x is in the exponent. Okay, and nothing to any power will ever give you 0 as a solution if you take it to a power. To a power, yep. So here we go. We got our points here. Okay, I know that 20 is a little bit off, but we're just going to go with it to make this graph work. Okay, there you go. It's a nice exponential decay. Okay, I predicted at the beginning, since this was positive, it would be above the x-axis, and it is. So, just talk about the domain and range now. The domain, anything x can be from the left to the right. So, once again, from negative infinity to positive infinity. And the range, the lowest point, okay, looks like this time it's going to be at 0 because it's never going to go below 0. 0 is our boundary. It's a parenthesis because we're never going to cross through 0. It's not included. It's just a boundary point. And the highest point would be positive infinity. It goes up forever.